Alright, let's have a look at ketones. Okay, so I mentioned in my video on aldehydes that the following organic compounds have a carbonyl group, which is a C with a double bond to an oxygen. The oxygen being more electronegative, meaning that this is a polar bond with this being the negative end and this being the positive end. So ketones are one of the organic compounds that has a carbonyl group in it. Okay, the difference between ketones and aldehydes is that aldehydes have the carbonyl group at the end of the carbon chain, where ketones have it somewhere in the middle of the carbon chain. Okay, so it's a non-terminal carbonyl group. A carbonyl group, that means not at the end of the carbon chain, somewhere in the middle. The suffix is anone, so methanone, pentanone. Sorry, you can't have methanone. Propanone, butanone, and so on. We use a number to indicate the location of the carbonyl group. So in this case, the carbonyl group is on the second carbon, so pentan 2-one. In this case, it's on the third carbon, pentan 3-one. With propanone, there's only one possibility. It has to be in the middle, so there's no number required. Same with butanone, it can only ever be on the second carbon. Physical properties. So we talked through these with aldehydes, but let's go through it again. Aldehydes and ketones have similar properties. They are polar as long as the carbon chain is short. When the carbon chain gets too long, they behave non-polar. They don't exhibit hydrogen bonding between molecules, but they can hydrogen bond with water, which makes them more volatile than alcohols or carboxylic acids. Short chain ketones are soluble in water because they're considered polar. As the carbon chain gets longer, the non-polar part becomes more significant and outweighs the polar part, and they become insoluble in water. Ketones have a sweet smell. It's one way of distinguishing them. So let's have a look at preparation and reduction of ketones. Ketones can't be oxidized, which is another way that we can distinguish between ketones and aldehydes, but we'll get to that. Okay, so how do we make a ketone? Well, we oxidize a secondary alcohol. Okay, so we have to begin with an aldehyde. We oxidize a primary alcohol. With a ketone, we oxidize a secondary alcohol, where the OH is somewhere in the middle of the carbon chain. And basically what happens is the OH gets replaced with the carbonyl group, and we get a ketone. So it needs to be a strong oxidizing agent, such as dichromate or permanganate, and also an acid as a catalyst, and also heat is often used to produce a ketone. Now, we'd normally do this under reflux because we want to add heat and acid. But the problem with that is that as we're heating it, we may end up evaporating our ketone as it's being produced. So in order to prevent it being lost, we use reflux, which is where we have we circulate cold water around this tube, so that if the ketone is evaporating as it comes up, it will get here and get colder and condense and fall back into the reaction mixture, so that we don't lose the ketone that we're making. If we wanted to capture the ketone separately from the alcohol, well, actually, no, yeah, there's two ways of thinking about this. If we add enough oxidants to completely oxidize the alcohol, then eventually, after we've done this reaction under reflux for long enough, we should have no alcohol left and only ketone left. If we wanted to capture the ketone separately, another way we could do that is using distillation. And if you want to see an explanation of how that works, look at the video on aldehydes, and you'll see an explanation of how distillation works there. Okay, reduction. Just as a secondary alcohol can be oxidized to a ketone can be reduced to a secondary alcohol using sodium borohydride in alkaline conditions, just the same as we reduce an aldehyde to a primary alcohol. Okay, an important distinguishing test between aldehydes and ketones. Aldehydes will be oxidized by an oxidant. They will oxidize further to a carboxylic acid, and so we'll see a color change in dichromate. Dichromate will be reduced from orange to green. As it oxidizes the aldehyde, it itself will be reduced from orange to green, and we'll see the color change. We will see no color change with a ketone. Okay, no oxidation reaction between the oxidation and the ketone. So the chromate will have no reaction, it will stay orange because we can't further oxidize a ketone, but we can further oxidize an aldehyde. So it's an important distinguishing test to tell between the two. Okay, so that's ketones.